Alright, so today we are going to study Xlnet. That is very interesting topic over here. Okay, so in Xlnet we have in the last lecture we have studied about BERT, and in BERT what we do is it's basically encoder, and we have several things that are available to us, like it performs pre-training, and then in the second pass, so it has two steps. First is it does pre-training, and second is it carry out task or application whatever it is meant to do, maybe language modeling or sentiment analysis or question answering, anything. And in first pass, what it does is, what BERT does is, basically it generates, uh, it masks out 15% or some percentage of words from its whole data set. It masks them out and predict those words. So instead of traditional language modeling, it will mask out certain words and predict those words in first step. And in second step, using that information, it will go on. Now we will see what Xlnet does. So I had a look at this BERT. So BERT was given to us in 2018, and this Xlnet is BERT was state of the art. It performed really well on many NLP tasks, but Xlnet outperformed BERT in few of these things. We will see how, and we'll see architecture and details about Xlnet in this lecture. Now let's see. So BERT was basically, we have discussed already in last class. It can perform so many things like question answering, natural language inference, sentiment analysis, document ranking, and it performed really well. And architecture of Xlnet is similar to BERT, but with one modification, and that modification lies in the pre-training procedure. We will see how and why it is required. So there was disadvantage of BERT. So can anyone say what was the disadvantage of BERT? Okay, think about, because BERT what we are doing is, several words are missing in the whole sentence, and those words are picked randomly. Okay, so if you can see, like in a traditional language modeling, when we are doing it, so what, suppose we have a sentence, um, I like eating chocolates. So in traditional language modeling, what happens is, I have word I'll predict what is the next word, like. Now I have I like, what is the next word, eating. I have I like eating, what is the next word, chocolate. So this is my traditional language modeling task. Now in BERT, what it does is, it masks out certain words. Let's say it masks out this like, and says, okay, what is the word that was over here. Okay, so BERT was not considering the sequence. Some random words are masked out, so it is not considering the ordering of those words. Now, what if two words are related to each other? In that case, BERT will not perform well. For example, okay, if I am talking about Taj Mahal, Taj Mahal is situated in Agra. And let's suppose Taj and Mahal, these two were masked out. Okay, situated in Agra. So now these two words are masked out. So instead of Taj, suppose it is predicting red fort. Okay, so it predicts red and it predicts Mahal. Both of these are correct, because these two are, these are places, monuments, and it's forming a correct sentence. So if first word it is predicting red, so that is correct. And if second word it is predicting Mahal, because these two words are not interrelated, no ordering is there, and no dependency of first on second is there. Okay, so in that case, BERT fails. So BERT fails whenever we are considering the sequence or dependency between any two words, because it is not considering that dependency which was there in the traditional model. But there is also a disadvantage of the traditional model, that it is considering only few words that it has looked earlier in the sentence. It is not looking at the whole sentence as a whole. Okay, so both of these traditional language modeling, as well as both of and as well as BERT, both of these are having its own pros and cons. Okay, so this is what, so Xlnet utilizes pros of both these approaches. So there are two types of language model. First is autoregressive. In autoregressive models, that is, each token can look at previous one. For example, it will you are given first word, or maybe you are giving initially start a token, and you want to predict first word. Then you have two tokens, you want to predict third word, you have three tokens, and you want to predict four words. So this is autoregressive. And then second option is auto encoding model, where you mask out certain words and you predict those masked words from the whole sentence at once. So while you are training it, so all these words are getting predicted at once. Okay, so these two types of models are there, and pros and cons we have discussed. Like in auto encoding, we consider, although we consider the whole sequence. We have suppose sequence was very long, so we consider the whole sequence, only few words are masked out, so it will get trained better. Okay, so this is advantage. While disadvantage is, what if these two words were dependent on each other? What if these two words very important in the formation of that sequence? Okay, so that thing is not there. So this is a disadvantage. Now in autoregressive, what was the advantage? That, like, they are considering dependency. And disadvantages, it is only first word is considered for predicting second word. Only two words are used for predicting third word. So this is a disadvantage. Whole sequence is not considered. Okay. So what Xlnet does is, Xlnet combines pros of these two approaches. So it considers the whole sequence. Also, it considers the ordering. So Xlnet combines the pros of each of these approaches. And let's see. So this is the example. So I'll open up the research paper that proposed this Xlnet. This was a research paper, generalized autoregressive pre-training for language understanding, uh, given by this research team. So when they proposed this Xlnet, so it outperformed BERT on 20 tasks, including question answering and all these tasks. So it outperformed BERT, and it is a very latest paper. So what it does is, in pre-training, it enables bidirectional learning, bidirectional context, by maximizing the expected likelihood over all the permutations of the factorization order. Factorization order is like, okay, we'll discuss this in detail. Then overcomes the limitation of BERT thanks to autoregressive formulation. So it combines the autoregressive plus BERT. Okay, BERT was auto encoding, so it combines the advantages of BERT as well as autoregressive. Now they have given one example, so that was good. Yes, over here. So suppose we want to predict a New York in a sentence. Given is a city. So what BERT will do? So sentence was New York is a city. Okay. So what BERT will do? Simply it will mask out New and mask out York. Mask these two words and predict each of these. So the overall probability that it will calculate was based on New given is a city, and York given is a city. Now what Xlnet does is, it adds whatever it has seen previously. Now so the disadvantage of BERT was, it can predict New over here, and suppose another city is maybe Los Angeles, so it will predict Los over here and York over here. So that would also be fine. But in X, for as far as In Xlnet, what do they propose was whatever it has already seen. So suppose it has predicted new, and it has predicted new. So this new will also be considered while predicting York. Okay, so whatever it has seen. So as soon as I give my first training example. Sorry, I give my first training example as input to my model. So as soon as I give my first training example as input, it will predict something. So as soon as I give second training example, it will reorder the sentence, and it will use the word that use the probability that it has already seen in the with the previous training example. Okay, so as soon as new training example comes up in the data set, it considers whatever it has seen previously. So this is the advantage in Xlnet. So it is a modification. So Xlnet was a modification of BERT, and this paper was given in 2019, and I think BERT was in 2018. So these are very, very latest uh, models. Now let's have a look at what it does. If they have shown. Okay, so they have not shown it graphically. Now let's see so how they have done it. Let's have a look at it. Suppose I have a sentence, this same sentence, suppose New York is a city. New York is a city. And I want to predict New York and is a city was given to me. So as soon as my first training example comes up, what I'll do, I'll train, and I will train on this. Suppose, okay, for this I will give, suppose I have given a random ordering. So I have given ordering 1, 2, 3, 4, and 5. Okay. And I want to predict fourth and fifth word in the sequence. Okay. So for this, what I will do is I will train on 1, 2, 3, and I will train on 1, 2, 3. Again, I will train on and predict this fourth word. And again, I will train on 1, 2, 3, and 4, and I will predict this fifth word. Okay. So what it is doing is it is considering BERT architecture by masking out two words, and it is also considering autoregressive. Why? Because it is considering whatever it has seen previously. So it has seen previously fourth for new. So it is also considering that. Now next time what I will do is I will, so this is one ordering. Now what I will, this is I'll do in first pass. In second pass, what I will do is I will change this ordering. So what I will do is I will, let's say, want to predict again um, New York is a city. So I will say, okay, 1, 2, 3, 4, and 5. So I will train on first 1, 2, 3, and I want to predict maybe fourth word. So this is maybe city. So this is it will train on 1, 2, 3, and it will give fourth word as output, whatever it is. And next time whenever new training example comes up, what it does is it will use 1, 2, 3, 4, and it will predict fifth one. So this is how this Xlnet works. So every time you are every time so it considered two things. So even for activation as well, what it will take is it will take as input all the so whenever it is calculating the probabilities, it will take input all the terms that it that are appearing previously. Now there are two things. First thing is okay, so because sequence is it is considering the previous sequence also, and it also requires to, because in BERT what happens is at once whenever you are training it whenever you are training BERT, so all the masked words, suppose A, B, C, D, E were there, so B and D were masked. So whenever you are training BERT, B and D will output at once. So it will output B and it will output D at once at time t is equals to 1 at same time. So this Xlnet also does the same thing, but the only difference is it will give output after one pass. So after it has trained, so in one pass, basically it is considering the sequence as well. It is also considering the previous terms as well. So it is autoregressive. Plus, it is also giving output the fourth word and fifth word at the same time. Similarly, it is also outputting the fourth word and the fifth word at the same time after second pass, after the model is trained for the second pass. Okay. So this is the architecture of Xlnet. Now let's have a look at. So similarly, they have proposed this architecture and they have compared it with many other models, and definitely this Xlnet was better. Mm, let's have a look at. Yes, they have given example. So first of all, they have considered this factorization order 3241, and they want to predict, let's say, maybe third word. So because third word is, so they have considered the order 3241, and they want to predict third word. So this is like language modeling where we are predicting the starting word in the sentence. Okay. Then again in the second pass, what they will do is they will change the factorization order and they want to predict third word again. Now because they have information for second and fourth, so they will train it and they will predict the third word. Okay. Similarly, they so every time so every time they want to each and every time they are training, they are just changing the factorization order. Factorization is we are dividing sentence into a set of words, and they are changing that order, and according to, and this order is selected randomly. So they are every time they are considering some random sequence. So sequence is there because dependency they are considering, and secondly they are also masking out some random words. So it is a combination of these two. Now let's see, let's have a look at if they have given this. So this is clear up till here. Any doubts?